This is Algebra 1, Saxon's third edition, and lesson 113, and this lesson is on direct variation and indirect variation. So when you see a problem that says that two things vary directly or two things are directly proportional, we say that one of those variables is expressed as a constant multiplied by the other variable. So here's some examples of things you might see in problems. The number of boys in the classroom varies directly as the number of girls. The number of girls is directly proportional to the number of boys. The weight of a substance varies directly as the volume of the substance. Force varies directly as the current. The circumference of a circle is directly proportional to the length of the radius. So in each of these examples, we would set up the equation with one variable. For instance, the force varies directly as the current. So force times the other variable, force equals the other variable, current, multiplied by a constant, which is K. So to solve these problems, you'll set it up this way. It'll be like a multiplication problem. But you first have to find out what K is, what the constant is. Let's look at how to do that. So example problem 1 says the mass of a substance varies directly as the volume of the substance. If the mass of 2 liters of the substance is 10 kilograms, what will be the volume of 35 kilograms of the substance? So first we need to, if it's 10 kilograms to 2 liters, we need to find out what it is to 1 liter. So doing that, just like a proportion, 2 over 10 reduces to 1 over 5. So it would be 5 kilograms for just 1 liter. Now knowing what that is, 5 is the constant, okay? So it's the thing that's not going to change. But then we're going to change the mass to 35 kilograms, and we're going to try to find out what the volume would be if we did that. So we go to this same formula, mass equals the constant times the volume. We know that the constant now is 5, and we know that we've changed the mass to 35. So 35 equals 5V, and then to get V by itself, we simply divide both sides by 5, and we find out that the volume then would be 7 liters. In the next example, it says the distance traversed by a car traveling at a constant speed is directly proportional to the time spent traveling. If the car goes 75 kilometers in 5 hours, how far will it go in 7 hours? So again, we have to find out what that constant is. If it goes 75 kilometers in 5 hours, then we know that distance equals the constant times the time. So the distance is 75 and the time is 5. What is the constant? Would be 75 divided by 5, which is 15. Now we know what numbers to plug in. We want to know the distance, and we know that it's 15 times 7 hours. And 15 times 7 is 105, so the distance then would be 105 kilometers. In problem 3, it says under certain conditions, the pressure of a gas varies directly as the temperature. When the pressure is 800 pascals, the temperature is 400 K. What is the temperature when the pressure is 400 pascals? Alright, again, we have to find out what this constant would be. So if the pressure is 800 and the temperature is 400, we solve by dividing both sides by 400. We find that the constant is 2. So the pressure equals 2 times the temperature, other words. So if the pressure is 400 and it's 2 times the temperature, we divide by 2 on both sides and we'd find out that the temperature would then be 200 K. Alright, now conversely, which means kind of on the opposite side, when a problem states that one variable varies inversely as the other variable, or the value of one variable is inversely proportional to the value of the other variable, then we're going to use division as our setup type problem. Inversely means sort of like it's the opposite of directly proportional or varies directly. So here's some examples that you might see. The pressure of a perfect gas varies inversely as the volume. So we would set that up as pressure equals the constant divided by the volume. The current varies inversely as the resistance. So if you see this, you know you're going to set it up as a division. So current equals the constant divided by the resistance. The velocity is inversely proportional to the time. So velocity equals the constant divided by the time. Here's an example problem. Under certain conditions, the pressure of a perfect gas varies inversely as the volume. When the pressure of a quantity of gas is 7 pascals, the volume is 75 liters. What would the volume be if the pressure is increased to 15 pascals? Alright, well, we're going to set it up like this. Pressure equals K over V. And we know that 7 is the quantity. The pressure is 7 and the volume is 75 liters. We need to find out what K is. Well, we would simply multiply by 15 on both sides. 75 on both sides, and find that K in this problem is 525. So then we put in, if we change the pressure to 15, that would equal our constant 525 divided by V. Now I'm going to teach you a shortcut. Instead of trying to figure out a way to solve this, you're going to say switch the 15 and the V that's over here on the bottom. Just switch places with them. Now we have V equals 525 over 15, and when we do the division we find that the volume then would equal 35 liters. Example 2, to travel a fixed distance, the rate is inversely proportional to the time required. When the rate is 60 kilometers per hour, the time required is 4 hours. What would be the time required for the same distance if the rate were increased to 80 kilometers per hour? Alright, rate equals constant divided by time. The rate is 60 and the time required is 4. So we multiply by 4 on both sides and we find that K is 240. So our constant is 240. Now we're going to change our rate to 80, from 60 to 80, and use our constant here to find the time. Then we're going to do our shortcut. We're going to switch 80 here and T here. So T equals 240 divided by 80, and then that would mean that the time would be 3 hours. Okay, so let's do our practice problems, and this is A. I've already worked it out, but we're going to talk through it. The mass of a substance varies directly, okay, that tells you it's going to be a multiplication setup, as the volume of the substance. If a mass of 30 kilograms of a substance has a volume of 6 liters, then what is the volume of 65 kilograms of the substance? So we have mass equals a constant times volume. The mass in this first instance is going to be 30, and the volume is 6. So we divide by 6 on both sides, and we find that our constant then is 5. All right, now we're going to change the mass from 30 to 65, and we're going to put in our constant of 5, and we're trying to solve for the volume. When we do, we need to divide both sides by 5, and then we find that 65 divided by 5 is 13, so the volume then would be 13 liters. All right, in B, it says, under certain conditions, the pressure of a gas varies directly as the temperature. So varies directly is going to be a multiplication. So let's, pressure equals K times T, temperature. When the pressure is 1200 pascals, the temperature is 300 K. And that K is kelvins. Okay. So what is the temperature when the pressure is 300? If we reduce the pressure to 300. Okay, so let's find this first. We need to find our constant. We're going to divide both sides by 300. 1200 divided by 300 is 4, so our constant then is 4. Go back to the same setup, K times T. Now the pressure is going to be 300 instead of 1200, and we know that 4 is the constant times the time. If we divide both sides by 4, we find that the temperature is 75 Kelvin. Okay, one more. Under certain conditions, the pressure of an ideal gas varies inversely as the volume. That tells me it's going to be a division setup. When the pressure of a quantity of gas is 9 pascals, the volume is 100 liters. Alright, so we've got pressure and volume. So pressure equals K over V. Alright, the the pressure in this first instance is 9, and the volume is 100. So we'll multiply both sides by 100. 900 equals K. Now we're going to start over here again. If the pressure is increased from 9 to 20, 20 equals 900 over V. We're trying to find the volume. Alright, so we're going to switch the 20 and the V, switch places. V equals 900 divided by 20, and 900 divided by 20 is 45 liters. Okay, good job. I'll see you back next time for lesson 115, because we are going to skip lesson 114. Not that it's not important for you to know, but I do not require a graphing calculator for this particular book. I will for the next book, the Algebra 2 book, but the first part of the lesson on exponential growth, you can look at that and you can figure out how to do, just on a regular calculator, how to figure out exponential growth of, say, your money in a savings account. But the rest of it, we're going to leave the graphing calculator stuff until next year. So I'll see you next time for lesson 115.